expect perfection from you. Never mind. Okay, so we're going to look at the first 13 questions of the spring semester test review. The first part here says simplify each and state the excluded values. So we've got basically a fraction. And in that fraction, you've got a polynomial on the numerator and on the denominator. So in a situation like this, what you don't want to do is you don't want to start canceling pieces. Remember, these expressions are all held together and can only be canceled if the entire thing is the same from top to bottom. And we don't have that going on right now. So you're not canceling pieces, you're not crossing out these individual a's that changes the expression. You're not going to divide 12 by 3 or anything like that. So what we do is we look and we say, is there anything that can be simplified on the top or the bottom? And I see that the top can factor. So I'm going to try that. And if I can factor it, if anything can cancel at that point, I'll do that. So I look at the top, the factors of 12 that add up to -7 would be -4 and -3. So I'm going to factor the top into a minus 4 and a minus 3. Now there's nothing that can be done on the bottom, it's only a minus 3. So I'll just leave it the way it is. And now when I look top to bottom, I see that I do have two a minus 3's. Those can divide evenly, basically becoming 1, and so they in effect cancel. So I'm left with only a minus 4 on the top, divided by 1, which doesn't really change anything, so we'll just put a minus 4. Okay, now it does say state the excluded values, so we don't want to stop here. Excluded values would be any values that make the expression untrue, and if you look at the denominator at the beginning, we have an a minus 3. Now I know that I cannot divide by 0, so my question is simply, what would make the denominator 0? Because I can't divide by 0, that would make the expression undefined. So if a were 3, then I've got 3 minus 3 is 0. That wouldn't work. So out here next to the answer, a minus 4, I'm going to put that a cannot equal 3. Okay, because if a did equal 3, the expression would be undefined. The whole thing would not work. Okay, we're going to do the same thing again on number 2. The only difference is number 2 is a little bit messier. So let's see what we've got to work with. Again, fairly large expressions here. On the top, I see that everything is divisible by 6, and there's an x in both. So I'm going to go ahead and take out a 6 and an x. That leaves me x squared minus 54 divided by 6 is 9. Now I see that I can go ahead and factor that, but I'll do that next. So let's go to the bottom. The bottom, I see that everything is divisible by 3. So I can take out a 3, and that leaves me 7x squared plus 20x minus 3. Okay, and that appears like it probably could factor as well, so I think I need to keep going. I've got more things that can factor here. So going back to the top, x squared minus 9, that's a pretty simple factoring. Factors of -9 that add up to 0, that would be -3 and 3. So I can break x squared minus 9 down into x minus 3 and x plus 3. And then on the bottom, that one's a little bit more complicated. We have to factor either by bottoms up or by grouping, whatever you prefer. Bottoms up is a little faster, we'll do that. So factors of 7 times -3, that would be factors of -21 that add up to positive 20. That would be 21 and -1. Okay, so we've got, I'll go ahead and put it underneath, we've got x plus 21 and x minus 1. Now remember, with the bottoms up method, both of those need to be divided by 7. So that makes my answers x plus 3 and 7x minus 1. If it cannot divide evenly, you move it to the front. So we still have our 3, but now we have an, did I say x plus 7? Yeah, I'm in x plus 3. whatever 21 divided by 7 is. X plus 3, and then the other one is 7x minus 1. Okay, so that one took quite a bit longer to get simplified down, but now that we've got it simplified down, we should be able to very quickly and easily see what parts are the same and what parts can cancel at this point. So I've got an x plus 3 that they both have in common. Those can divide evenly. And I have a 6 divided by 3. 6 divided by 3 is 2. Nothing else is in common, so nothing else can cancel. So whatever's remaining, that is our answer. So our answer at the top, 2x times x minus 3 divided by 7x minus 1. Now we still need to state the excluded values. So again, I would go back to before anything was canceled. And because it's not factored at the beginning, this is probably not going to be as easy to figure out what is excluded, nor is this. It's probably easier to look at what's excluded when it's factored, but before things are canceled. So x plus 3 would be negative 3 would make that 0. So if x is negative 3, the whole thing is undefined. So x cannot be negative 3. And then x cannot be plus 1 divided by 7, 1/7. X cannot be 1/7 either. Both of those values would make your expression undefined, and neither one of those is okay. All right, any questions 1 and 2? Any issues, anybody? No? Okay, let's move on. We're looking at 3 through 6. These are all addition, subtraction, multiplication, division. And it looks like we've got 1 subtraction, 1 multiplication, 1 division, and then number 6 is complex. It's got 2 parts to it, so we'll just go in order here. All right, when you subtract or add, subtraction and addition, you need to have the denominators the same. You can't add fractions that don't have common denominators. For example, if you had 1/2 plus 1/4, you're not going to add literally 1/2 and 1/4 together. What you're going to do is you're going to make 1/2 be written as 2/4, and then 2/4 plus 1/4 is 3/4. So when we add fractions or subtract fractions, the denominator has to be the same before we do anything else. And so in a problem like 3, we don't have any way to make an n plus 2 turn into an n minus 5. So the best way to make them the same denominator is to go ahead and just multiply the thing that each one doesn't have. So the right side needs an n minus 5, so we'll multiply by n minus 5. The left side needs an n plus 2, so we'll multiply by that. Now that makes the denominator good to go. As long as the denominator is the same, that's what we'll have in our answer. N plus 2 times n minus 5. Now the numerator is where you have to do a little bit of work. So we need to go ahead and distribute the 4 on both the left and the right sides. So that would make that 4n plus 8 on the left, and it would make it 4n minus 20 on the right. Now this is a subtraction problem. So 4n minus 4n would be 0n. We don't need to write anything there. And 8 minus negative 20, that would be 8 plus 20. It's 28. So the only thing left on the numerator is 28. Now at this point I would say if anything can cancel or divide away, go ahead and do that, but there's nothing there that will cancel, so we don't need to worry about that. That is your answer. And the direction just say to simplify, so we're done. All right, so moving on to number 4. Okay, when you multiply, multiplication really is just finding anything after you simplify that can cancel, getting rid of it, whatever remains is your answer. Okay, simplification just means basically divide away anything that you can to make it as simple as possible. And in these we've got 4 separate expressions. two of those expressions, the top left and the bottom right, can factor in some way. And so we want to go ahead and do that so that we can see what will cancel and what won't. So I'll start by just factoring the top left. They both have an 8 in common, and they both have an x squared in common. Now if I take those away, that leaves me an x plus 48 divided by 8 is 6. Go ahead and mark that out so I don't get confused on what I'm looking at. The top right and the bottom left have nothing that can simplify, but the bottom right can factor as well. So if I factor the bottom right, factors of 12 that add up to 8, that would be 6 and 2. So x plus 6 and x plus 2. Get rid of that again. Okay, so looking at what I have available to me here, I see that I have an x plus 6 that can cancel. I see that I have an x squared and an x. Now that's x to the third, and that can cancel with this x to the third. So I'm going to get rid of all of those individual x's. And that leaves me just on the top 48, and on the bottom 24. 8 times 6 is 48. So I've got 48 divided by 24, and then an x plus 2. Now 48 divided by 24 is just 2. So those can actually cancel as well, leaving me with just 2. So my final answer is 2 divided by x plus 2. Okay, now again, don't get carried away here and try to divide those 2's out, because that's not a 2 on the bottom, it's an x plus 2. And an expression needs to stay together. You can't cancel parts of expressions. Okay, so don't get too carried away in all your simplification and get rid of those 2's at the end as well, because that would make your answer that was right wrong. Okay, so moving on to number 5. Number 5 is actually the same question as 4. It's just written in a very different looking way. Remember, you're looking at two fractions, and this line here is a divide line, so we're actually taking a fraction and dividing by another fraction. Now when you divide, it's better to not ever even actually thinking of dividing. It's better just to say, okay, we multiply by the reciprocal. So I'm going to write this down and make it look like 4. I'll put the first fraction down. And then for the second fraction, because I don't want to actually divide, I want to multiply by the reciprocal, I'm going to go ahead and just put a multiplication sign, and I'm going to go ahead and flip the second fraction around. M plus 5 moves to the top of the fraction, 3m minus 9 moves to the bottom. Now that 5 looks just like 4, the process is no different. We try to factor out anything we can. It appears that all but one of these will actually factor at least a little bit, and then anything that's in common will cancel and move on. So at the top I see that I'm looking for factors of negative 21 that add up to 4. That would be 7 and negative 3. 7 times negative 3 would be negative 21. They'll add up to 4. There's nothing you can do with m plus 5. Now on the bottom we have factors of 7 that add up to 8. 7 and 1, that's all you have. And then finally over here on the bottom right we have 3m minus 9. Now there's not a lot you can do, but you can take out a 3. So anything that you can do to factor out these before you try to simplify is good. That'll help you see what they have in common and what they don't. So now looking top to bottom, I see an m plus 7 on both. That can go away. I see an m minus 3 on both. That can go away. And that appears to be everything. So whatever remains is my answer. That is as simple as I can make it. So the simplified answer here is m plus 5 on the top and 3 and m plus 1 on the bottom. 3 times m plus 1. Okay, moving on to 6. Okay, on 6 we have a complex problem here where we've got actually a subtraction problem put inside of a division problem. So when you look at this, it's really 3x plus 2 divided by 5x. That fraction is divided by these fractions down here that are being subtracted. So before I can do my division, I need to go ahead and do the subtraction. So I'm going to treat this part here kind of like part 1. Okay? So treat that like a completely separate problem, and then we go ahead and do the division next. So that problem, again, is subtraction, and when you add or subtract, remember we have to get the denominators the same before we can do anything else. So when denominators like these that are completely different are here, it's easier just to multiply by each other. So the right side needs to have an x, so I'm just going to multiply the right side by an x. The left side needs to have an x plus 2. So I'll just multiply by an x plus 2. Now that makes the bottom of my fraction x times x plus 2. That part's pretty simple. Now the top is where we need to actually do the subtraction. So we need to subtract the left minus the right here, and before we do that we probably want to go ahead and multiply them out. So x plus 2 times x plus 2, that would be x squared plus 2x would be plus 4x. Plus 2 times 2 would be 4. Now, it's a subtraction problem, so minus 4x times x. That's minus 4x squared. Okay, now I can go ahead and simplify the top here. X squared minus 4x squared, that would be minus 3x squared plus 4x plus 4 over x times x plus 2. Okay, so that is your denominator. Okay, the subtraction problem here turned into this expression. Now, we need to go ahead and do the division problem. So the division problem is 3x plus 2 divided by 5x. That's the first fraction. Now, we're not going to divide. We're going to multiply by the reciprocal. So now we're going to multiply by x times x plus 2 all over negative 3x squared plus 4x plus 4. Now, the left two are already as simplified as they can get. The top right is already simplified. So the only thing I really need to look at here is, can the bottom right one be factored out in any way? And it might be. Let's look. Let's see if there's anything that'll work. So negative 3 times 4 is negative 12. Are there factors of negative 12 that add up to 4? If there are, then we can do bottoms up. And I know that 6 times negative 2 will get me negative 12, and 6 minus 2 will get me 4. So I can do that. Now that means that I've got x plus 6 and x minus 2. But because there's a number in front of x squared, we need to do the bottoms up method. So I need to divide them both by negative 3. That's going to make this first one x minus 2. And that's going to make the second one negative 3x minus 2. Now from here, I would tell you to go ahead, since they're both negative, I would just pull that negative out in front, and I would make both of these positive. So we've got negative, and then in parentheses x minus 2, and then 3x plus 2. Alright, so I'm going to get rid of all of this that I've simplified, and I'm going to see if there's anything now that can cancel top to bottom. So I see a 3x plus 2 on the top and on the bottom. Those can go away. And I see an x on the top and the bottom. Those can go away as well. Now the x plus 2 and the x minus 2, they look really close. You say, is there anything I can do there? No, those need to stay. They're not the same expression. Just because they have the same number doesn't mean that we need to try to do anything with them. So we're left with an answer of, on the numerator, x plus 2. And on the denominator, we've got a 5 and a negative and an x minus 2. So negative 5 times x minus 2. Okay, guys, any issues on that? No? We're good? Jake? Good? Yeah? Max? Okay. All right, so let's look at the next section. Now we are solving. So now we're actually going to get an answer. When it says solve, you want to have x equals something. It says remember to check for extraneous solutions. So these would be solutions that, it looks right on paper, but you plug it back in, it doesn't work. So when we get done, let's always check our answer and make sure that it actually works in the problem. So generally speaking, the easiest way to solve when you have fractions is to get rid of the fractions, get rid of the denominators. So when you see something divided by x, well, it makes it a little bit harder, so why don't we just multiply by x and divide them away. Say, well, you can't just do that. No, but you can if you'll multiply everything by x. So as long as you multiply each term by x, you're algebraically still fine. So we multiply everything by x, the denominators both go away, and you're left with a much simpler problem of 2 plus 1 times x is x equals 1. Now 2 plus x equals 1 is really simple. So we took something that looked fairly complicated, we made it fairly simple. So if I subtract 2, I've got x equals negative 1. Now it does say remember to check for extraneous solutions. So I would go back to the original problem, plug it in, and make sure that it works. So 2 divided by x is negative 1. 2 divided by negative 1 is negative 2. Plus 1 equals 1 divided by negative 1 is negative 1. So is negative 2 plus 1 equal to negative 1? Yeah. So we checked it. It does work. That answer is not extraneous. Okay. Always good plan anyway. Go back and check your work. Make sure that it's right. All right. Let's move on to number 8. This one has quite a bit more on the bottom. That's okay. So the first thing that I would do here is factor this one on the left out and see if there's anything that it shares with the other one so that I don't have to multiply by all of this, because that would make a big mess if I multiplied everything by x squared plus 4x minus 12 and these two. Okay? So if I factor that out, factors of negative 12 that add up to 4 are positive 6 and negative 2. Now that makes things a whole lot easier for us, because now when you look at the denominators, the only things that you see on the denominator are an x plus 6 and an x minus 2. So we're going to multiply every single term by the things that we see on the denominators. An x plus 6 and an x minus 2. We'll do that on all of them. So everything gets multiplied by an x plus 6 and an x minus 2. Now, the far left, they'll both cancel. I have an x plus 6 and an x minus 2. The middle term has an x plus 6 that can cancel. And the far right term has an x minus 2 that can cancel. Now let's look and see what we're left with. On the far left, we're left with x squared minus 5x plus 7. In the middle, we're left with a positive 3 times x minus 2. So if I distribute that, 3 times x minus 3 times 2. And on the far right, we're left with an x times an x plus 6. That would be x squared plus 6x. Okay, now we've got a lot of terms, so let's do some cleaning up. The first thing I see on the left is that we can distribute, or we can combine like terms. So I see a minus 5x and a plus 3x. That would be minus 2x. And I see a 7 minus 6. That would be plus 1. Okay, I also see that if I subtract x squared, they'll go away. So I am left with negative 2x plus 1 equals 6x. And again, that is a much simpler problem than what I started out with. So I can solve that pretty easily. Add 2x to the right. That would make that 1 equals 8x. And then divide by 8. X is equal to 1/8. Okay, moving on to 9. Sure. Okay, moving on to 9. Yes, ma'am. Yeah, I thought about it, but it would take way too long, so I didn't. All right, so number 9, we are attempting to solve this one as well, and I see that the far left doesn't have denominator, but that's okay. You're still going to multiply it with whatever is on the other denominators anyway, and I see that the bottom one here in the middle can factor, so I want to go ahead and do that. So k plus 2 and k plus 1. Now that means that every single term needs to be multiplied by k plus 2 and k plus 1, even the one over here on the far left. So k plus 2 times k plus 1, and do that for all 3 terms. Now nothing cancels on the far left. They all cancel in the middle. And the k plus 2's cancel on the far right. So we are left with k plus 2 times k plus 1 times 1, which is really just k plus 2 times k plus 1. That would be k squared plus 1k plus 2k. That would be plus 3k plus 2. Plus 2k squared minus 9k minus 5 equals k minus 4 times k plus 1. So that would be k squared plus 1k minus 4k. That would be minus 3k. And negative 4 times 1 would be negative 4. Alright, so from here, again, we need to do some cleaning up. I see that I've got 2k squared and 1k squared. That would be 3k squared. I see that I've got a 3k and a minus 9k. That would be minus 6k. And I've got a plus 2 and a minus 5. That would be minus 3. Now I've also got a squared term, a linear term, and a constant term on the right side as well. So when you have quadratics and the x and the squareds won't cancel out, the best thing that you can do is get everything put on one side and then try to factor. If you can't factor, you can do the quadratic formula, some other method. So let's go ahead and let's just subtract all of the terms over here on the right side to the left. And then we can factor or do the quadratic formula or something. So if I subtract k squared, that would make that 2k squared. And just put that over here. If I add the 3k, that will make that minus 3k. And if I add the 4, that will make that plus 1 equals 0. Okay, so I have officially moved everything to the left side, so it equals 0. Now, if I want to find the zeros, I can do that by factoring by the quadratic formula. You could do completing the square. If you had access to a calculator, you could graph it and look for the zeros that way. But we're going to try factoring because it's usually the quickest and the easiest. So are there factors of 2, 2 times 1 is 2, that will add up to -3? And -2 times -1 will multiply to 2, and it'll add up to -3. So that would be k minus 2 and k minus 1. Now, because there is a number in front of k squared, we need to go ahead and divide both of those by 2, by that number. If it divides evenly like this one, it would just k minus 1. If it doesn't divide evenly like this one, we move the 2 up front. So 2k minus 1. That means my solutions are k equals 1 and k equals 1/2. Now we probably need to go ahead and check for extraneous solutions. So if I'm plugging this in up here, let's start with the one that should be pretty simple to plug in. And I'm going back to the original problem. Let me start on the right. The right looks a little easier. 1 minus 4 is -3, and 1 plus 2 is +3. So -3 divided by 3 is -1. And then I've got 1 over here plus. Now, 2k squared minus 9k minus 5. If k is 1, 1 squared is 1, times 2 is 2. 2 minus 9 times 1 is 9. So 2 minus 9 is -7. Minus 5, that's -12. And then on the denominator, if k is 1, 1 squared is 1, plus 3 times 1 is 3. 1 plus 3 is 4, plus 2 is 6. So we have 1 plus -12 divided by 6. That would be 1 plus -2. That would be 1 minus 2, which is -1, equals -1. So the 1 works. Now let's try the 1/2. And I'm going to run out of room, so let's just try this. Okay, so we've got 1/2. We're going to plug that in. And again, I'll start on the far right because that'll probably be a little easier. 1/2 minus 4 is -3.5. And 1/2 plus 2 is 2.5. So we've got -3.5 over 2.5 equals 1 plus. Now we've got 1/2 squared is 1/4 times 2, that would be 1/2, minus 9 times 1/2. So 1/2 minus 9/2, that would be -8/2, that would be -4. Minus 5 would be -9. On the bottom we have 1/2 squared is 1/4 plus 3 times 1/2, that would be 3/2, plus 2. That's a mess. Okay, so 1/4 plus 3/2 plus 2. That would be 3.75. Well, that's a pretty mess. Okay, so we have -3.5 times 2/5 if I multiply by the reciprocal. And over here we have -9 times, that would be 15/4, 4/15. (5/5) minus 12/5 is -7/5. That one works as well. Okay, so number 9, they both worked. Kind of complicated checking without a calculator, wasn't it? Yeah. Okay. Any issues other than not wanting to check without a calculator? No? Okay, let's speed through these last 4. At least they'll go quickly. All right, you've got 4 cubic problems that we need to factor completely and solve. And so in the first 2, 10 and 11, we're just doing grouping. So if we do grouping here on number 10, first 2 and last 2 together, what do they have in common? Pull that out. So the first pair has a 7x squared in common. The second pair has a negative 3 in common. You'll always have the same thing left in each one, 7x plus 5. That's how you know you're doing it right. So we've got 7x squared minus 3 equals 7x plus 5. And it does say to solve, so if you get the solution to the right one here, that would be negative 5/7. And if you get the solution to the left one here, it would be positive 3/7, but it's squared, so we would take the square root of 3/7. Now the square root of 3/7, that would be the square root of, multiply both the top and the bottom by the square root of 7. That would be plus or minus the square root of 21 over 7. Okay, let's move on to 11. I'll move back if you need me to, but I want to hurry before we get stopped by announcements. If we get stopped by announcements. All right, number 11. Grouping. We've got a 7v squared that can be pulled out of these. That leaves me 6v plus 1. And a negative 3. That leaves me with 6v plus 1. So I've got 7v squared minus 3 and 6v plus 1. Those are my factors. Now if I solve, negative 1/6 for the one on the right and positive 3/7 for the one on the left, but it's square rooted as well. Now we just did that over here on the number 10, so that answer I already know is going to be the square root of 21 over 7, plus or minus. Okay, and then the last 2 are just factoring. They're quartic functions, but they're in the same format that you factor anything else. So factors of negative 24 that add up to 5. That would be 8 and 3, so 8 and negative 3. The only difference is that since it's a quartic, both of them are squared. So we solve both of them after we factor. The one on the left would be the square root of negative 8, which is actually going to be plus or minus 2i square root of 2. And the one on the right would be the square root of 3, and it's plus or minus, so plus or minus the square root of 3. Yep, I don't know why I have v. I guess the last one had v and I got carried away. Okay, and we'll do the exact same thing on 13. So on 13, factors of negative 28 that will add up to 3, that would be positive 7 and negative 4. And so, well, the one on the right's the easiest. The square root of 4 would be 2 and negative 2, so plus or minus 2. And the one on the left would be negative 7, square root of negative 7, so that would be plus or minus I square root of 7.